Yeah.
So it's a pleasure to have here my good friend, Dr. Khaled Al-Hassanieh. We met in Tallahassee when he was doing his PhD and I was doing my postdoc. So Khaled got his bachelor's at American University in Beirut. Then he got his PhD at, this was 2001, he got his PhD at Florida State University with Elvio Dagoto in 2007. Then he spent 4 years with Christian Batista at Los Alamos National Laboratory doing a postdoc from 2007 to 2011. And then he got another postdoc at Oak Ridge National Lab in Tennessee with Elvio Dagoto from 2011 and 2014. And he has worked as a software engineer, senior software engineer, and a lead engineer in 3 different companies, Fidelis Cybersecurity, Block.one, and Bullish. And he's going to talk to us about these companies in his talk, which is titled Working in the Private Sector as a Theoretical Physicist. So, Khaled, thank you very much for accepting the invitation. And I pass you the microphone.
Okay, thank you. Thanks, George. Hello, everyone. It's good to be here again. Let me share my slides. Okay, so as George mentioned, I'll be talking about job opportunities for theoretical physicists in the private sector. I'll go over my experience. So after 2 postdocs, I switched to work in industry. First, I was a software engineer at Fidelis Cybersecurity, and then later on a senior software engineer there. There we worked in cybersecurity, obviously, and the job combined both software. So the first half of my work there was just pure software development, and then then after that I started working in machine learning and combined both machine learning and software. And then I moved to another company called Block.one, and it works in the blockchain space. Blockchain, cryptocurrencies, that type of work. And I did mostly just software there. And then we started building a cryptocurrency exchange, and the exchange split into its own company, and that's where I moved. And the new company is called Bullish, and it's a cryptocurrency exchange that is up and running, and that it has now one of the largest trading volumes in the world in the crypto space. And there I do both software and financial math. So I split my time between the two. Spend maybe a third doing math and 2/3 writing software and doing testing on the software that we write. So a few points that I want to make here is that any information that I present here is based on my experience and my experience only. It doesn't represent in any way the policies of the company that I work at. And anything that I recommend here is definitely not exhaustive, but it's just meant to be a starting point. Starting point for preparation and training to transition from academia to industry. And I will mention like the pros and cons of each career path. And these cons and these pros and cons are based on my personal opinion. Everyone should obviously do his or her own research and reach their own conclusions. So there are a few categories where we can work. As theorists, of course. The first is software development and or engineering. The second is machine learning or data science, and the third one is financial math or quantitative analysis. They usually call them quant for short. Or there are jobs that combine one or two, more than one of these jobs. So you can be doing software development and quantitative analysis, or machine learning and quant work, or any combination, basically. There might be more, but I think for me, these are like the main categories that we can look at. So I'll go into each of these in some detail. I'll start with the software engineering. Pros, it's a vast job market, huge job market. There are jobs available in almost every city. Remote work is becoming more and more common. And as physicists, we have a strong advantage in a subset of these jobs, not all of these jobs. So if the jobs involve some math, some math component, then we're in a very good shape, because we have a very strong math background as if we're trained as physicists, and that's definitely stronger than the math background of people trained as computer scientists. The cons, it's different from the traditional physics training. It's the skills that you need there are not what you see in your training as a physicist. Though they're not difficult, you can pick them up, but you need to do the work. You need to do the preparation, and there is a substantial preparation required there. So to start to do the job preparation, you need to look at what's required. Of course, different jobs have different requirements specific to those jobs, but there is like an overarching set of skills that are usually required. So you need to be proficient at least one programming language. I'm biased towards C++. I think for us as physicists, C++ is a natural choice. There are other choices that include Python, Java, Scala, C#. And I'll get into a little more details about that. Whatever programming language you choose, you will need some basic computer science skills. And these include data structures, such as linked lists, arrays, binary search trees, hash tables, etc. And algorithms, searching, sorting, dynamic programming. These data structures and algorithms are independent of the language. So if you, or C++, if you, because that's my main programming language, so I know more about it than other languages, obviously. And if you take that route and you decide to teach yourself C++ and train more in C++, here are things that you need to consider. C++ is difficult to master. I mean, of course, you can learn the basics, but to become proficient at C++, it's very difficult. So that's an advantage and a disadvantage. An advantage is because it sets you apart And the disadvantage is because it requires a lot of work to and training to become proficient. So good C++ engineers are usually difficult to find. So if you're one of them, that is definitely a big plus. And what's required as a C++ programmer? Object-oriented programming, classes, inheritance, polymorphism, pointers and references, move semantics, and that's starting from C++ 11 and forward. Lambdas, templates, basic templates. You don't need to begin with. You don't need to be extremely proficient at templates, like template metaprogramming and so on. Also required is good knowledge of the C++ standard library.
Khaled, yeah? Sorry, you are not sharing anymore for some reason.
Oh, okay. Let me.
Your camera went off and the sharing stopped.
That's strange. Let me. Okay.
Your camera is back and you are sharing again.
Okay.
There is some instability somewhere.
Yeah. Okay. So I was saying another requirement is C++ standard library: containers, vectors, maps, sets, lists, strings, algorithms, iterators, smart pointers, streams. So this is a general knowledge of the standard library. So this part here of the preparation, if you take the C++ route, or actually any language, but here the details are specific to C++. As part of the interview process, sometimes you have conversations, general conversations, and in order to have a meaningful conversations during the interview, you should have built a small project. So you set up a Git repository. If you're using C++, you use CMake to compile the code, and you use a testing framework. If it's C++, then you use Catch2 or Boost.test. There are other testing frameworks. So basically, it's a complete project from setting up the repo, writing the code, building it, and writing tests for it. Tests it as part of the code itself, or I mean, as part of the project and the repo. Also, if you're taking the C++ route, you should familiarize yourself with at least one C++ Boost library. Again, this is not strictly required; it's just a good talking point. And you familiarize with yourself with how memory works, stack versus heap, caching, etc. This is general. This last one is general computer science knowledge that is definitely good to have. So for some resources for software engineering, programming exercises, are these two sites, LeetCode and HackerRank. I'm more familiar with LeetCode. There are a lot of programming exercises there, and you at different levels and cover different areas, and they allow you to use different languages. You can use C++, Java, Python, C#. I don't know what else, but quite a few languages. It's enough. And you solve these problems, and they get graded. They test them against many test cases and check the performance and so on. So this is a great resource for exercises. But before you start doing the exercises, you need to actually study the material first. So there are online courses on Coursera. Many different courses there. I find very useful. There's a data structures and algorithm specialization offered by UCSD. It's a 5-course specialization. Obviously, if you can take the whole 5 courses, that's great. But if not, the first 2 courses should be enough as a starting point. There's another specialization offered by Stanford that's very similar. I'm not familiar with that one. I'm more familiar with the UCSD one. At udemy.com, there are many courses there, and usually the courses there are shorter and more focused, like more focused on a subtopic and shorter. So you can find a lot of courses there, and including C++ courses, obviously, and many of the courses cover like a subtopic, so threads in C++, or standard library, or functional programming in C++, etc. So both of these places are a great resource to start. If you choose C++, here's some reading material. I would recommend learning from these courses, but if you want to get read more or get deeper into the topic, these are some books. Effective C++, Effective Modern C++, and there's High Performance C++ High Performance. This is a great book, and it's very up to date. And I point out the chapters here that are more important than the rest. This one here, from mathematics to generic programming. It's not really required, but it's a great read if you get deeper into how things are designed based on math concepts. So the other category is data science and machine learning. So the pros, it's a growing job market. It's growing, and it's still not as large as the software market, but it's growing. And as physicists, we have a strong advantage there, a very strong advantage, I would say. And what you need there are skills that are similar to what you learn in physics: calculus, linear algebra, basic statistics, which as physicists we should be very comfortable with. The cons, I don't see really any cons there. It's just that it's a smaller market than software, but for us physicists, I don't see any other cons. So what are the general requirements here? Python programming language is the main language used in machine learning or data science, and so Python programming and some packages related to that are used in machine learning. So scikit-learn, there is NumPy. There are a few packages that are used. So that covers really the language part, and then the algorithms. So you need to have a good knowledge of supervised learning algorithms, neural networks, decision trees, random forests, linear and logistic regressions, and so on. So supervised meaning that you have labeled data, and you divide the data into training part, testing part. You train your algorithm on the training part, and you test it against the remaining of the data. The other set of algorithms is called the unsupervised learning algorithms, like k-means clustering. This is when you don't have labeled data, and knowledge of general machine learning concepts and techniques like regularization, bias versus variance, etc. So any course, like good course on machine learning, should cover all of these algorithms and concepts. Some knowledge of SQL databases. It's not always required, but it's good to have. if time permits. And projects is definitely a big thing in preparing for jobs in data science and machine learning. And when you build these projects, it would be good to have a Git repo, same as in software, to have a Git repo and post them there, so you can refer to them in your applications. So some resources, Kaggle.com is like, it's the main site for machine learning. There are courses, projects, competitions, data sets, anything really is there. There are many courses on Coursera. So there is, the main one is machine learning course offered by Andrew Neg at Stanford. This is the, in my opinion, at least, this is like the absolute must starting point. This is where you learn the general concepts, the algorithms, and it has homeworks and exercises. This is a great point to start. And if you want to learn more, there is a machine learning specialization offered by Washington University. And if you want to focus on neural networks and deep learning, there is a specialization called Deep Learning Specialization offered by Andrew Neg, same as the course here. And this is a great place to learn neural networks and deep learning, which is a subset of machine learning. The third category is quant jobs, financial math. The pros, it's heavy on math. Like, you need advanced math there, and it's definitely math heavy. And as physicists, we have a strong advantage. They like physicists in that domain. The cons are that it's a small job market. It's definitely not as big as the first two. Small job market, limited to financial centers like New York, London, Hong Kong, Chicago. Some big cities in the US, maybe Houston, some jobs in Houston, some jobs in LA. But it's a smaller job market and centered in a few places. But I'm gonna talk about it here anyway. Some requirements for this job: stochastic calculus, options pricing, Black-Scholes equation. Black-Scholes equation for them is kind of like Schrödinger equation for us. It's a fundamental equation. Good knowledge of probabilities, Monte Carlo simulations, binary trees. This is an algorithm specific to financial math. Partial differential equations. You don't need to be an expert in partial differential equations, just to the extent that they are used in options pricing. Interviews also usually include puzzles, brain teasers, like logic problems. So many companies in that domain don't require financial math knowledge and focus on general math modeling, but financial math would be a plus in these companies. I listed this website here. It's a little old, but still useful. So some material for preparation for quant jobs. John Hull book, Options, Futures, and Other Derivatives. This is a large book. You don't need to read all of it, but I listed the chapters here that are good to know. This is like the authority in options and futures and financial derivatives in general. But it's more geared towards business students, so the math there is a little weak. It's not very rigorous, but it's good to have, it's good to learn the concepts there. Financial calculus. This is a very good book. It's a short book, but very good book to learn financial calculus. It's much more rigorous than the first book. Introduction to probability models. This is a math book. Obviously, it's not necessarily a financial math book, but it has the ability. So I say first 5 chapters. They have the probability knowledge that is required for these jobs. Computational methods in finance. That's a great book, but it's more advanced, and it's if time permits. And here there are 2 books that have quant job interview questions, like questions and answers, of course, and they're both good. I recommend the second one, Joshi. So, okay, before we move on, so what I want to say about quant jobs is that, like I mentioned, it's a small market. It's as a beginner, and if you want to optimize your chances of getting a job in industry.
It happened again.
Okay.
Your camera went off, and then right after the sharing, I stopped.
Yeah. Okay. Let me.
There is a timer or something. Your microphone is off. Okay. I can't hear you. I can't hear you. Can't hear you. The microphone doesn't seem to be off, because there is no symbol in your name here, but I can't hear you, and the sharing is off too. Do you want to go out and come back again? Maybe this will solve the problem.
I don't think he's listening to you.
Can you hear me, Khaled?
Now it's working apparently.
It's working.
Okay.
Okay.
Your microphone is working, but it's not sharing yet.
Okay. I need to be presenter again.
Edson, please.
Yeah, there you go.
Thank you.
Okay.
Okay. Okay.
All right. So I was talking about the about quant jobs, and I included it here as a category. But if you want to optimize your chances of getting a job in industry in general, I would recommend focusing on one of the first 2, the software or machine learning. and because it's a much bigger job market, and then later on you can train yourself in finance and move on to the financial sector if that's what you want. So some websites for jobs: Indeed.com, Dice.com, Monster.com, CareerBuilder.com. The first four are general for any job, basically. And eFinancialCareers.com, it focuses on jobs in the financial sector. So so good luck, and please connect on LinkedIn. And if you have any questions, please feel free. Sorry about the disconnections.
No, that's fine. Macs and these platforms don't go together well. So thank you very much, Khaled, for this nice talk. And we are open for questions. We have above average number of people in the audience today. So anything that involves making money captures the attention of the students.
Rafael, I have a question.
Rafael?
Oh, yeah. Thank you, Dr. Khaled, for your talk.
Sure.
I have just two questions. What struck me is that you, for most of the career path, let's say, you have provided books, but not for deep learning. Why is that?
Not for deep learning?
Yeah, you have not shown any books, any resources.
That's not by design. I can provide books on deep learning or machine learning in general. It's it's like this for me at least. For finance, I learned almost everything from reading books, right? For software, C++, I learned from both courses and reading books, and doing exercises. For machine learning, it was mostly from courses. That's basically there is no like deeper reason for that.
Okay, it's like you find more helpful to the courses and
in machine learning I found it much more the courses at least I found very helpful. Especially that first course by Andrew Nag, this general machine learning, that was extremely helpful. And if I want to learn more on like some specific thing, I research it. There are either papers or websites or sometimes books, but I didn't go through a book fully through a book from the beginning to the end when it comes to machine learning. So that's it.
Okay, and the second question is, I don't know if you do interviews, but what do you expect actually from your from the candidates in general, and not, let's say I apply for not junior nor senior, in the midterm there. What do you expect from the candidate?
Yeah, so we expect so right now we're interviewing for software. We call it quant engineer, so it's mostly software with some math. So what we interview, what we require, first, just general problem solving. This is kind of abstract, and a lot of times, it's very vague. But like from the CV, from projects they worked on, we can kind of tell that they have worked on challenging projects and they have good problem solving skills. But that's kind of abstract. The other thing we require is a knowledge of the programming language that that they will be using. So it depends on the job. Some jobs say, look, as long as you have a very good algorithms and data structure knowledge, then you can pick up the language. Even if you, let's say, you know C++, but we're interviewing for a Java developer, you can say, well, you can learn Java, so you'll be okay. But a lot of times we require a knowledge of the specific language because let's say we're working on a project and we're under a time constraint, so we want someone to start working immediately and start producing immediately. So data structures and algorithms and one programming language. That's basically what we require for software jobs.
Okay, and if I may, just another question. Can you share what you thought was or were the main challenges you faced in the transition?
Sure. Yeah. The job market was still bad at that time. It was still recovering from the 2008-2009 crash. So I started preparing for finance jobs. That was a mistake for me. I ignored the programming, data structures, algorithms, and I just studied financial math. And at that time, the job market in finance was pretty bad. So that was not helpful. And I realized with time, I was doing more interviews, was that they focus much more on programming and algorithms than the math part. So then I started learning programming and algorithms and data structures and C++. I knew C++, but not to the extent that is required. So that was the challenge mostly is learning these concepts or these skills. So basically self-training. At that time, I wasn't really aware of jobs in machine learning and data science. Had I known, I would have probably chosen that, because that is definitely more suitable for a physicist, and we have a strong advantage there as physicists. But that's a smaller job market than software, I would say.
Yeah, okay. If I may again.
Sure.
I'm all over here, sorry, people. And what about, did you start, the transition during your PhD, or it was later on? And between the first interview and the last, or let's say between the day of the point you decided, yeah, this is where I'm going. How long it took you to finally arrive at a first job, or say the first defining opportunity for you in the field, please?
Yeah, so I started during my second postdoc, not during my PhD, and it took really like 2 years. 2.5 years, everything like preparing and doing the interviews and everything. But I would say it took longer than it should have, mostly because of the job market at the time. And another reason was that I started preparing for finance jobs, and then I switched and started preparing for software jobs. So that kind of that took more time. But if you focus on one of them, that should save you some time, I would say.
Thank you.
Sure.
I have a few questions. Maybe the students should ask questions. I already have a job, so I don't need to. But anyways, I was reading that the job market in general right now is quite hot. This may change next year because we are apparently we are heading into a recession. But I read that there is 1.5 jobs per person who is looking for a job. So there are more jobs than people looking for jobs. Do you see it that way in your field?
Yeah. The job market is hot. That is true. I don't know what's gonna happen in moving forward, because it looks like it's slowing down. I know some big companies have stopped hiring, and I know of one large company in the crypto space that canceled. They made 700 job offers and they canceled them after they made the offers. So it looks like it's slowing down. It's still good, but looks like it's slowing down. But if for students, they have time, right? Even if the market goes down, and it will go back up again. And if you're a student, you have time, and you should prepare gradually, like over a year or 2 years. Just prepare gradually. Spend some time. It's easier said than done to do the time management. But if you over your tenure as a student, if you spend a small fraction of your time over 2-3 years, you'll be in a very good shape.
Okay.
I have a question.
Go ahead.
Suppose Khaled. By the way, thank you for your nice talk.
Oh, sure.
Suppose you have been working on theoretical physics for since your PhD. It would be like 15 years, right? And now, apart from the slowing down with the market, would you change field or a job because if you learn about this thing, would you still think it would be how to say attractive?
Yeah. So you mean like if I was still
Yes.
in physics now?
You probably would have a position, I assume, because you.
Yes, I am assuming you are positioned like no better than I am. I have.
I don't know.
Would you change? I'm not thinking about that because I think I'm too late.
Well, it's a different word. It has its advantages and it has its disadvantages. You work on different type of problems. You're less independent in industry. You have to work on what you have to work on, right?
Mm-hmm.
You can't just drop a project, and it's the stakes are higher. If, for example, we built a cryptocurrency exchange that holds billions of dollars, literally.
Ooh.
So if you a bug there, if you make a mistake, it can be extremely costly.
It can cost your neck, right?
Yeah, exactly. That is taken into consideration. So testing is a huge part of the work, right? We have to write all kinds of tests, and even with that, then there are still get bugs in production. But so far, I mean, luckily we hit some bugs, but there wasn't anything crucial or anything critical. Like it's a minor inconvenience for the user, but it's not to the extent that we lost anything, which is good. I mean, you hear about bugs in Facebook or something, right? That come out even after, even years after Facebook started. You still hear sometimes there is a security hole in Facebook. So all of these things, it's a different world, and it's ultimately up to you, like what you like and what you don't like. And another, that's kind of a disadvantage, but an advantage is that it's much more flexible, and you're much more mobile. Because in academia, you're mostly in the same place for most of your career, right? In industry, you move, you have a lot more mobility. So after a few years, you can decide, look, I'm done with this company or with this city or with this state, and I want to move somewhere else. And you can usually find a job and move to that place.
Mm-hmm.
So, yeah, it's these advantages and disadvantages that you want to weigh. I'm glad I made this switch. That's, for me, I'm glad. So
Good. Thank you.
sure.
I think Rafael has another question, but I think George.
Go ahead.
Go ahead, Rafael.
I'm representing all the students. I'm making all the questions possible. Sorry. I think one of the things that motivates us to stay on academia is, the research thing, to be there, at the edge of knowledge and being challenged. Do you feel challenged in your job? Is it enough in that, let's say, intellectual vanity that we have, we solve hard things and do this stuff that no one has done before. Do you have that thrill in your job? Do you I don't know, what motivates us and what motivates you in this aspect? Do you feel satisfied in your job in this dimension?
Yeah, I do, and that I know that's not always the case. I worked on some especially my first job. I worked on some projects that were not really challenging. It's just work that needs to be done. But now in my current job, I definitely feel challenged because there is a strong math aspect to it, and we have to derive equations. We have to derive formulas. We have to come up with our own algorithms. We can't just copy a formula from somewhere. And we can there are challenges that come up regularly, and we need to find a solution. We need to solve them, and we need to solve them in an optimal way, meaning that the solution must run fast so that the users have a good experience. So yes, definitely, it is challenging, and we have that challenge, definitely. That said, there are always times, and even in physics, there are times that there is work that you need to do, and it's not exciting, but you just need to. Sometimes, like writing tests can be challenging too, because you need to come up with different scenarios, and and for example, in my work, I wrote simulations to simulate the market. That's for testing, to simulate the market and see if everything is going well, right? Simulate thousands of users sending thousands of buy and sell orders, and seeing that everything is working properly. But then how do you decide everything is working properly? So you come up with with equations and invariants that you need to test. So that was very interesting work. Overall, it's quite interesting, yes. But that's not necessarily the case everywhere. But for me, at least, in this job, it's been quite interesting.
Thank you very much.
Sure.
I'm afraid Rafael is too interested in this area. He's my student, so
He is very student.
you should stop asking questions, Rafael.
No, don't listen to him.
I was just going to make a comment you said about how difficult it is to debug software to make sure that a complicated software is completely free of possible failures. I know of two large-scale projects. One is the most advanced fighter jet of the American Air Force. Mm-hmm. That the jet itself has been ready for years, for many years. What they cannot get right is the software that controls the fighter jet.
I see.
It's not, nobody's flying it the way it should be flown with all the software controlling everything, because the pilot wears a helmet that has a special software that controls everything. And this software doesn't work. Mm. And they have been testing it, and because if there is a bug, then it's one less pilot. And who wants to fly a fighter jet that you may have a bug in the software that controls everything? And the other one is a NASA spaceship that has been built already to explore comets. So it has to have a flight trajectory that goes together with the comet, and the comet is going at hundreds of kilometers per second, and it has to land in the comet. And the spaceship is ready. The hardware is ready. It has been postponed for another 6 years because they cannot get the software ready.
I see.
Because they cannot spend a few $1 billion in the spaceship, and then there is a bug in the software and the spaceship crashes into the comet. They have to make sure that the software is working. So are two similar problems, but it just shows that it's not easy to write a code. I always tell that to my students. It's almost impossible to write a code that doesn't have a bug. You just don't know where the bug is, and you don't know when it's going to show up, right?
Yeah, that is true. I completely agree. And for helmets and devices, you're very limited because you have very limited memory.
Okay.
Right?
Yeah, sure.
There is like embedded programming. It's a whole field by itself because you're constrained with the resources. You're constrained with memory and CPU time. So that's another challenge for programming software for devices.
Okay.
Small devices. And also regarding being at the forefront of knowledge, in fields like AI and machine learning, it's the companies that are now at the forefront, right? It's not really. I don't think academia is at the forefront. It's the Googles, the Facebooks of the world that are at the forefront. And if you look at innovations like blockchain, that didn't come from academia, that came from industry, and things of that nature. So it is definitely it has its own challenges.
Okay. So, but you shouldn't tell that to to Rafael. Otherwise, Edson is going to be.
He still have 3 years to go.
3 years to
His
go.
PhD. You should tell him, Khaled. Without a PhD, he cannot get a job.
Yeah, that's true. That's true.
Yeah.
Having a PhD, it's important, right?
Oh, definitely, especially if you go into data science and machine learning or finance, they require at least a master's, but usually PhD. A master's has to be from a top place. If you have a master's from MIT, Stanford, those places, they would consider as enough. Sufficient for these jobs, but in general, it's a PhD, especially in physics, right? I mean, if you have a bachelor's in computer science, you can get an entry-level job in computer science. But in physics, you need a graduate degree.
I'm just kidding. He likes physics.
Okay, well, that's good.
So if there are no more questions, we should thank the speaker again. Thank you very much, Khaled, for the.
All right.
Very
Thank you,
nice
everybody. I wish I was giving this presentation in person in Brazil. Hopefully, one time in the future.